Okay, hello. Today we're going to cover how to use a calculator to find inverse trig functions, solve them, evaluate them. So what we're going to be doing today is just a bunch of example problems because the lesson's not that hard. Essentially what I'm going to ask you to do is to evaluate these things. We're not going to need triangles. We're not going to need unit circle. What we're going to use is the calculator. Okay, so, well, hold on. Just making sure it's presented. All right, so when you do this problem, it's actually, for some of them, it's very, very basic. If you have arc sine, there is actually a button on your calculator that says arc sine, or rather cosine inverse. So if you look at over here, above the cosine button, where my finger is, you'll see there's a cosine inverse here. So if I wanted to solve this problem, or I guess it's sine, I would hit second sine, and that would give me a space to write my number. Now I just type in 1.12, press enter, and there you go. That's the answer. Okay, so like I said, some of these are going to be very basic. Not much to it. It says rounded in 4 decimal places on the homework, so I'm going to round to 4 decimal places there. Okay, all right. Cosine is the same way, so I want you guys to try it. So pause the video, try typing that in. Shouldn't be a big deal. Okay, here you go. Second cos, negative 0.75. You don't even need to close the parentheses. You can just hit enter, and there you go. 2.4189. Okay. And even tangent will work. So if you want to do it, go ahead and type second tan, and then type in 4. Okay, there you go. You should only be doing this for problems that are not unit circle values, okay? If I give you a square root of 3/2, you should not be doing this. You should be using your traditional, well, I guess for tangent you would, but you wouldn't do it for cosine or sine, okay? All right, now that's the easy section. For regular sine, cosine, and tangent, it's simple as going to your calculator and typing in sine inverse. Now, if you're using Desmos, let's pause for a moment. If you're using Desmos, you can do these as well. You can see I have Desmos over here. But instead of typing in the -1, just always use arc. Okay, so let's just type in arc sine 1.12. You see you get the answer. Oh, I wrote it wrong over there. Yeah, whatever. So yeah, there you go. You just type it in. You always use arc. You don't want to have to bother trying to make the little -1. You could, but you shouldn't. Okay. Now let's go to the second section here. You'll see I left this space for intervals, but we'll be working on that in a second. Right now, I kind of want you to understand how to just get these answers. Okay, so everyone go to your calculator then. If you think you understood part 1, where you just hit second, try to find cosecant on your calculator. All right, I'll give you a second. I'll pause the video, go look for cosecant. Come back when you found it. Okay, well, hopefully you didn't actually go and try because there is no cosecant button on the calculator. Okay, that's because, you know, in the old days, there just wasn't room for it. So what are we supposed to do then to get cosecant? Well, if you guys remember, cosecant is a reciprocal of sine. So like, you know, cosecant is, let's see, it's hypotenuse over opposite. So if cosecant is this, then we should be able to switch this. If we use the same numbers, but we make it sine, we can flip these two. And that's something we can enter into the calculator. Okay, because these two would give you the same angle, cosecant and sine, if you flip the ratio. As you can see, this is something I can type into a calculator. I can go arc sine or second sine. 1/4. And that gets me the answer. Okay, now, if you're using Desmos, I've been told it's okay for me to tell you this. Desmos actually, since it's not old school like these calculators, it can actually handle cosecant. So if you'll go over here and you hit arc cosecant, and 4, you'll see that you get the same answer, but without having to worry about the flip thing. Okay, so if you think you might forget how to do that, then go use a calculator. Arc cosecant 4. All right, so on this next one, let's try it both ways. Let's start by doing this one using the classic old school way, the way I learned it. So you're going to turn this into, so secant is cosine's inverse, or not inverse, but like the reciprocals. So you're going to flip this to -3/7 and type that into the calculator. So second cos -3/7. There you go. 2.0137. Now let's just check that on the Desmos. So I'm just going to hit arc seek -7/3. Yeah, got the same answer, you see? So the calculator on Desmos is reliable. You can use that. All right, let's go down to the last couple examples that I'm going to give you that we're using the calculator on. Everything else after this will be non-calculator, so just pay attention here. All right, so for this one, if you want to do it with the calculator, you just you turn this into tangent, right? Tan inverse of 1.7. You'll get your answer. This one is not going to be hard. You're going to get the answer, and it's going to make sense. So we're going to go do tangent inverse of 1.7. I got 1.039. Not too bad, right? The problem is if we get to this one. Well, actually, let me wait and come back to this one. I put a star by it because this one's going to be a big deal, but you guys won't understand why it's a big deal yet. So let's switch gears for a second. We're going to go to non-calculator mode. So I'm going to put away the calculator. Not going to need it for this next part. Put this away. All right. So the test will also talk to you about intervals. Do you guys remember the principal intervals of each function? How like sine has a principal interval that looks like this, from -π/2 to +π/2. Well, when we ask you to find the interval, what we mean is what quadrant, basically. What quadrant is this in? Now, if you know about signs, you know that negative signs go down to the bottom, positive signs are in the top. So because this one is positive, it's got to be in quadrant 1. So it's going to be in quadrant 1 here. It's going to be somewhere in there. Okay, now, if we're going to give the interval for quadrant 1, use your unit circle values. So quadrant 1 starts at 0 degrees, or 0 radians, and it stops at π/2 radians. So that's going to be the interval that we write down here. So the interval of this problem was 0 to π/2. It's based on the unit circle. Okay? So that just tells us that 0.12, the answer is going to be somewhere between 0 and π/2. And this, by the way, is between 0 and π/2. So it checks out. Okay? π/2 being like 1.7 something. So yeah, this is between 0 and 1.7 something. Let's look at this next one. So the next one says cosine of -0.75. Now you guys should know, here's the principal interval of cosine. This is how your teacher should have taught it with the half circle. So you guys know that it goes like that. Now this one is negative, so we know it's going to be in quadrant 2, right? That's going to be Q2. And quadrant 2, what is the interval? Well, it starts up top here. Quadrant 2 starts at π/2, and it ends at pi. So that's our interval. We're going to say pi over 2 to pi. Make sense? So essentially, you're just trying to match the quadrant where this comes from, or trying to match the quadrant where this angle comes from. Now, you might be thinking, is this correct? Well, remember, pi over 2 is like 1.5 something, and pi is 3.14. This is between that. So yes, it checks out. Okay, this is half of pi, so 1.5 something. This is pi, 3.14. This is between those two. So it is, in fact, in the correct quadrant. Now, you can do this with all of these, like tangent. We're looking at this tangent. We're like, okay, so where is this going to go? Tangent, since it's positive tangents are up here. So that's quadrant 1. We're going to say 0 to pi, or pi over 2. Since the top is an asymptote, we actually can't include it, but it is in quadrant 1. And look, remember this is like 1.5 something? This is within that limit, so it works. So do you guys see the match between the answer and the interval? On the test, you will be asked to find the interval. And it's really, you just need to know what's the principal interval, and then is the value positive or negative. Okay, so let's just fly through these next ones. I'll draw them for you. Here's cosecant. Cosecant is based on sine, so it's going to be one of those. I see that it's positive, so it's going to be this quadrant. So 0 to pi over 2. Okay, well, I guess technically it can't be 0, but we're not gonna try to get you with that. The reason being, sine is 0 at 0, so if you flip it, you get an undefined. Anyway, don't worry about that too much. All right, let's go to this one. So this is a negative, and it's a secant. So we should know that secant, this is based on sine, and x value is going to be from one of those two quadrants. It is negative, so it's going to be this one right here. And that interval is pi over 2 to pi. Okay, now we get to cotangent. Now remember, cotangent is a weird one. Cotangent and tangent aren't actually in the same quadrant, or the same semicircle. We know that cotangents look like this, while tangents look like, well, we saw it earlier, tangents are on the side. So you can see that there's actually going to be a mismatch. Now, on positives, it doesn't matter, because remember, all positive ones are in quadrant 1. So like all positive cotangents, all positive tangents, they're all in quadrant 1. So for us, this is going to be 0, pi over 2. That's where that one is. And now we get to the one that I said earlier is going to be strange. And let's see why. So if I did this using the graphing calculator, let me actually switch over to the graphing calculator now. Actually, before we do that, let's think about what we know. We know that cotangents are going to be on top of the circle. We know that this is negative, so it's got to be in this quadrant. Okay? So we're expecting it to be somewhere between pi over 2, which is like 1.5 something, to pi, which is 3.14. That's what we're expecting, right? So we're thinking that this should be our interval. Because it's negative and it's cotangent, it's going to be in that quadrant, so it's got to be between these two. But let's see what the calculator says. So if I hit tangent, I do second tan, and then I flip this, so 1 over negative 1.7. Let's see if I get an answer that's in the correct interval. Ooh, that is not in the correct interval. See? Now the reason for this is because when the calculator does tangent, the calculator is giving me an answer down here. Because the calculator thinks, oh, you're doing tangent, right? Tangent comes from these two. So the calculator is giving me an answer down here. But in reality, since I wanted cotangent, I actually wanted an answer to be over here instead. So what you're supposed to realize is, I basically just want to cross through the origin. I want to reflect to the other side. I want to go to the other side of the circle. And to do that, I add 180 degrees, or I add pi. So that means what you do is you take the answer that the calculator gives you. This is in quadrant 4, but we want it to be in quadrant 2. So we do that by adding half a circle to it. So we add pi. Second. Add pi. And that should be the correct answer. That answer is now between the interval that I established. Okay, so big takeaway here. If you're doing the cotangent of a negative, you need to add pi to whatever answer the calculator gives you. Right? Otherwise, you're not going to be in the correct interval. Anyway, so the point is, I'm going to write this down. The interval of this one should have been pi over 2 pi. The calculator did not give you an answer like that. So you need to be aware of that and just like be on guard. Let's see, cotangent is 0 here, so it's going to be a soft bracket. Okay. All right, so basically, for this lesson, you need to practice two things. Know what quadrant it comes from. That's a combination of is it positive or negative, and based on the principal interval of the original of the function. And then after you do that, the calculator part should be pretty easy. And just watch out for these. Those are the tricky ones. All right, that's it for this lesson. Try the homework. And yeah, hey, this is the last lesson of the unit. You'll be reviewing next time you see your teacher.